Hi, welcome to another exciting tutorial of Stream Developers. In this video, we will build a SwiftUI chat messaging and video calling application similar to Telegram or WhatsApp. We will use the Streams chat and video SDKs, allowing developers to build real-time chat messaging and VoIP calling experiences. To get started, visit the Stream website and go to Developer, Chat Messaging, and pick your favorite SDK. For video, go to Developer, Video and Audio, and select your favorite SDK. If you want to add only in-app chat to your iOS app, you can check this tutorial on our website. I will add a link to the description of the video. Also, if you want to add only video calling to your iOS application, you can check this tutorial on our website. Let's begin by touring the Starter SwiftUI project in Xcode. I'll show you how to install the chat and video SDKs and set them up. Then we will add animated reactions to our video calling experience and recap. The key features of the chat messaging support of the app includes the following. You can attach media of different types such as files, documents, photos, and videos. There is a message composer to easily compose and send your messages. Once you send or receive a message, you can react to the messages. There is an offline support, so you can browse chat history and channels without using the internet. With the chat SDK's customizable UI components, you can easily build unique chat experiences. Let's look at the key features of the video calling part. Using the Streams Video SDKs for building your VoIP calls. All calls will run on Streams Global Edge Network, allowing optimal latency and scaling to support many participants. Our video calling app can be used for making one-on-one and group calls. There is also picture-in-picture support, so during an active call, the local participant video turns into a draggable rectangle which can be moved around the corners of the screen. Let's launch our final project and look at what we will build in this tutorial. The app opens by presenting a list of chat messages. So here we can compose a new message and send it. We can also use reactions to react to messages. On the left side of the compose area, we have a button to attach images, videos, files and documents to messages. On the top left of the message list, we have this video icon. Once we tap the video button or icon, we launch the local participant's video. Here we have all these call controls for performing standard call operations. Tapping the emoji button shows animated reactions, like the chat messaging part. Here we can tap any of these buttons to show reactions. So this is basically what we will build in this tutorial. You can find this final project in this GitHub repository. I have different kinds of projects in this repository. So once you come here, you look into the folder iOS SwiftUI. Then you should select Telegram clone. So this is the Xcode project. You can also download it here as a zip file. Let's begin by touring the Starter SwiftUI project in Xcode, which I have already prepared for you to make things faster in this tutorial. In the Starter Xcode project, I have already created all these folders. We have the chat setup, video customization, and the call setup. In each folder, I have created some Swift files. Like here, we have custom channel view. Then in the video customization folder, I have all these files. In the call setup, I also have these tray files. So you can follow along by creating a new SwiftUI project in Xcode and add all these folders and the Swift files. Before we set up the chat and video SDKs, there is one important thing we need to configure, that is privacy. Our app will need to access the user's camera, microphone, and the photo library to perform some of its operations. On iOS, we are required to set permissions for camera, microphone, and the photo library usage. To add privacy for camera, microphone, and the photo library, we select the main app file and go to Info. The privacies are key and value pairs. So when I hover on any of these keys, you can see there is a plus button. Let's click that and go to the section Privacy. Let's select Camera Usage Description. Once we do that, we need to enter a custom string. We can also leave it empty to get a default title message from the system. Let's add the one for microphone. we will leave it empty as well. And finally, we will add the one for photo library. Once we add these privacy settings, we can now go ahead and add the chat and video SDKs. To add the chat SDK, we go to the toolbar and select File, Add Package Dependencies. In the search bar on the right, I will paste this URL. I will add the link to the description of the video. After adding the link, we should click Add Package. The Chat SDK is available for SwiftUI and UIKit. If the Chat SDK is not installed, you will also see a UIKit version at this point. So once you see the UIKit and the SwiftUI versions, you need to select only the SwiftUI version and click Add Package to install it. But let's cancel that because I have it already installed. You can install the Video SDK in the same way by going to the toolbar and selecting File, Add Package Dependencies. Here I will paste this URL. I will add the link to the description of the video. So this fetches the Video SDK from this GitHub repository. So here we need to follow the same steps as we did before. The Video SDK has three components. Stream Video, that is the core SDK component. Then we have Stream Video SwiftUI, consisting of SwiftUI components. We also have Stream Video UIKit, which is a UIKit wrapper for SwiftUI components. You can see here, Stream Video and Stream Video SwiftUI are disabled because I have them already installed. And we don't need the UIKit version, so I'm going to cancel the operation. So once you install the Chat and Video SDK, they will appear under Package Dependencies. Nuke provides support for lazy image loading and animated GIFs. We have Stream Chat SwiftUI, and Stream Video. Then we have the Serialization System Protocol Buffer for Swift. And the last one is WebRTC, which helps to establish the call. We now have all these package dependencies in place. Let's look at how we can configure the chat messaging part of the app in the next. From a production chat messaging app, you may want users to initiate chat from a list of channels or contact list. In this app, we are going to make everything simple. When the app launches, it will display the list of messages. So we are going to do the implementation in this main app file. In our case, we have facebubble app.swift. So setting up the Chat SDK requires the following steps. We first need to import StreamChat and StreamChat SwiftUI. In the app's closure, we will create an instance of the SDK's chat client. This has the variable config that takes a hard-coded API key. Next, we will create an optional StreamChat instance as a state variable. Then, we should connect a user using the connect user function. To access the Chat SDK and work with it, we need a valid user and user credentials. In this tutorial, we are going to use a hard-coded user with credentials. But for a production app, you can generate the user from your server side. If you don't have a server, you can use the Stream token generator service for testing purposes. You can do this in your Stream dashboard account using your API key. If you're new to Stream, you can sign up for a dashboard account for free. You can see our connect user function has a hard-coded token. We are using this hard-coded token for testing purpose. Over here, we use the chat client object we defined here to connect the user with the user ID, name, and avatar. And here we do a basic error checking if the connection fails. The last thing we need to do is to initialize StreamChat with the chat client and add initialization for the connect user function. In the app scene, you can see we are displaying a custom channel view. The custom channel view is located in the chat setup folder. So let's set it up. Here, we first need to import StreamChat and StreamChat SwiftUI. Then we will define the following properties. Here we create a state object to manage the logic of the chat channel. The state variable is video calling will be used for a video icon that we will place on the top left of the message list. Over here, we create an initialization of the chat channel view model using a channel controller. Let's change the navigation view to a navigation stack. Then I will add this sample code. In our navigation stack, we define a list of messages with all these properties. Then there is a message composer, which helps us to easily compose a new message. Also, we have reactions overlay view for adding reactions to messages. On the top of the screen, we have a toolbar consisting of a video button that toggles the state variable we define here. Finally, in the toolbar, we also display the default channel list header. So this is all we need to do to set up the chat messaging part of the app. We can now go ahead and run the app to see what we have done so far. You can see in the toolbar, my iPhone is selected. So I will click this button to run the app. That was successful. So once the app launches, it presents the list of messages. We can use the compose area to add a new message. On the left side of the compose area, there is a button to attach media like photos, videos, documents, and files. Using the lightning icon, we can add instant commands, Jiffy commands, mute and unmute users. By tapping and holding a message bubble, we can add reactions. So you can see on the top left, we have a video button. It doesn't show anything. Let's do that next. To add the audio and video calling functionality of the app, let's begin from the video customization folder by selecting the file call controls view. In the video calling part of the app, we want to add a custom call control for performing operations like muting, switching the camera from the front to the back, disabling and enabling audio, and more. In the call controls view struct, let's add the following properties. Over here, we create an instance of the SDKs call view model. In the video calling part of the app, you can tap an emoji button to show reactions. The reactions are presented using a bottom sheet. So this property is used to control the height of the bottom sheet. So once the bottom sheet is presented, you can change it from 0.1 through 1 by 0.1 using the map function. This property determines whether the reactions are showing or not. And these are for the video, audio, and camera controls. In the body computed property, let's paste this sample code. Over here, we have an edge stack for displaying the call controls. So we have all these buttons. A button for toggling the video, one for toggling the audio. We have another one for switching the camera from the front to back. Then there is another one that shows the reactions by presenting a sheet. The last one is a button for ending a call. So this is all about the call controls screen. Let's go to the next file, Custom UI Factory. By default, the Video SDK presents call controls view that looks like this. We can customize this experience using a custom view factory. To do this, we are going to use this file. You can see here we have imported Stream Video and Stream Video SwiftUI. Then we create the class Custom View Factory that conforms to the SDK's View Factory protocol. To learn more about the Video SDK's View Factory protocol, you can check our documentation. I will add a link to the description of the video. Finally, to override the default call controls, we need to use the method makeCallControlsView and display our custom call control view. So this is the file we created previously. This is all we need to do to customize the default call controls. To learn more about the various customization options, you can check our documentation. Let's move on to the next by adding the video reactions view. You noticed after configuring the chat SDK, we got the reactions for the messaging part by default. For the video calling part, we are going to add the animated reactions. The purpose is just to show you how easily you can add animated reactions to the video SDK. For a production app, I encourage you to check the reactions and custom events section in our documentation. For the video reactions view, once you tap the heart and thumbs up buttons, it displays an animation and a splash view. So the splash view is contained in this file. So here we have two circles arranged in this C stack. So we display this view along with the animations once you tap the heart and the thumbs up buttons. The reaction animations are contained in reactions view. Over here we have all these properties for the various emoji icons. we have this H stack for displaying all the emoji buttons, and for each emoji button we have two animations. The first animation for each button displays when the emoji button on the call controls bar is tapped. Then by tapping the emoji buttons themselves, we show these animations and the splash view. The thumbs up button also uses the new face animator in iOS 17 with a custom spring animation, and a similar animation is applied to the thumbs down button as well. So I encourage you to check the GitHub repo and explore in detail how all these buttons are animated in the file reactionsview.swift. So on the top section of the code, we defined all these initial animation states. We want the animation to trigger automatically. So when all these views appear, we need to add the onAppear modifier so that we can trigger the animation automatically by setting the final states of the animation. So here I will add the onAppear modifier. Then we set the final animation state for each of the buttons. You can see they all use Spring animations with different parameters. To trigger the animations in the preview, we can press Alt, Command, and P. So this is the animation that will be triggered when the emoji button on the call control menu is tapped. Like the chat SDK, to set up the video SDK, we also need a valid user and user credentials. Let's do the implementation in the call container setup file under the call setup folder. So let's open call container setup.swift. You can see here I have already imported Stream Video and Stream Video SwiftUI. Stream Video is the core video SDK. Stream Video SwiftUI consists of SwiftUI components for building video calling, live streaming, and audio room experiences. First, let's create an observed object for the SDK's core view model. Then we will define the following properties. The first one is the video client. Then we define an API key and user ID. We also have token and call ID. When we are done with the video SDK configuration, we need to fill all these placeholders. We need those credentials in order to run the app successfully. As I said before, for a production app, you need to generate the user from your server side. In this tutorial, we already have the user and the credentials already generated for you. You can find the user credentials in the video calling tutorial in our documentation. I will add a link to the user credentials in the description. So let's go to the video calling tutorial in the browser. You can find the user credentials under step 3. You can see we have the API key, so let's copy that and paste it in the Xcode project. I will go ahead and replace the other ones as well. Next, we need to create an initialization of the user and the video client. So let's paste this sample code. Over here, we create a user object with ID, name, and avatar. Next, we create an instance of the video client using the API key and the user. For testing, you can use the API key of your Stream account to generate a user token. If you're new to Stream, I encourage you to sign up for a free dashboard account to get started. I will add the link to the description of the video. And here we call the core view model. In the body computed property, let's change the navigation view to navigation stack. Then let's replace the text with this sample code. So over here, we check to see if the call is created. Then we present the SDK's call container with our custom view factory and the view model. The custom view factory is the class we created earlier in the file custom UI factory. So the custom view factory has this method, make call controls view. That is what we use to override the default call control from the SDK. When the call creation is in progress, we show the text loading. Finally, once all the views appear, we create and join the call with a call type and call ID. The default call type is used for video calling. There are also different call types, such as audio room, development, and live stream. You can also define your own call types in your Stream's dashboard account. If you don't have a dashboard account yet, I encourage you to create one for free. So this is all we need to do to set up the video SDK. We first define all these properties. Then we create a user with ID, name, and avatar. Then we initialize the video client with the API key, user, and token. We check to see if the call is created and present our custom view factory. And finally, we create and join the call. Next, let's open the file floating participant view. The local participant video is rendered as a floating rectangle during an active call. So we need to implement the local participant in this file. Over here, you can see I have imported stream video and stream video SwiftUI. Let's define these properties. We create an optional participant from the SDKs called participant and define the size. Next, let's replace the text in the body computed property with this code snippet. In summary, we check to see if the participant is not null. Then we use the SDK's video renderer to render the local participant view. The SDK's video renderer view helps you to display the local participant video without any calling UIs. To learn more, you can check our documentation. I will add a link to the description of the video. After adding the local participant, we need another view to display both the local and the remote participants. To implement that, we are going to use this file, participantsview.swift. I have already imported stream video and stream video SwiftUI. Let's add these properties over here. First, we add this property for the video call. Then we declare the participants as an array. Then we declare another property for the participant's video track visibility. Once the participant's video track visibility changes, we call this function. In the body computed property, we use geometry reader to get the position and the size of the participant's view. So over here, let's paste this sample code. In summary, if the participants are found, we use a scroll view to display each one of them by calling the makeCallParticipantView. We have an error here because we haven't created the makeCallParticipantView. Over here, if the call participants are not found, we display a black color. Finally, let's add the makeCallParticipant method. So here we compose the makeCallParticipantView with a view builder with all these properties. When the view appears, we set the participant's video track visibility to true. When it disappears, we set the video track visibility of the participant to false. So this is all we need to do to get the video calling part of the app running. First, we set up the video SDK. Then we add the local participant using the SDK's video renderer. Finally, we should display both the local and the remote participant. So we can now go ahead and run the app to see what we have built so far. Before we do that, previously I showed you how the video calling will be triggered. So let's go back to this file, custom channel view. On the top of the messages view, we added this toolbar. So to start the call, we tap on this button. Once we do that, we present the file call container setup in a full screen mode. The call container setup is the one we defined earlier that contains the configurations of the video SDK. On the toolbar, you can see my iPhone is still selected. So let's run the app. That was successful. So the app presents the list of messages. We can react to messages with a long press gesture. To start the video call, let's tap the video button on the top left. On the call control menu, we can disable and enable the video, mute and unmute the audio, and flip the camera. We can tap the emoji button to show these reactions. Now the call has only one participant. To add more people to the call, we're going to use the companion web app of Stream Video. From the video calling tutorial, I previously copied the credentials from. Let's click Join Call and click Join Call again. We now have two participants in the call, one from the web and one from the iPhone. This is all I have for you in this tutorial. I hope you have enjoyed it. You now know how to build an iOS app capable of real-time chat messaging and video calling, like your favorite and famous communication app, Telegram, WhatsApp, or Messenger. We only unlocked a single out of the many use cases of the chat and video SDKs. To learn more about the advanced features of our chat and video SDKs, I encourage you to check all the related links in the description of this video. Thanks for watching this tutorial.